Here, let us see this next question. So in this pulley block system, we are supposed to find out the accelerations of the blocks, pulleys, and what is the tension present in this string here. So if we observe this diagram, here this total is a single string only. So therefore definitely tension everywhere in this string should be equal. So if I take tension here to be T, here also tension is T, here also tension is T, and here also tension should be T only. Now if I take this pulley P1, then here it is given that tension is T, but here tension is 2T, T and T, 2T. And it is given also that these pulleys are all massless pulleys. So for massless pulleys, the upward tensions and downward tensions must be equal. So T is equals to 2T. So this condition is satisfied only when tension becomes 0. So throughout this string, tension must be equal, then only this condition will be satisfied. So here if tension is T and everywhere if tension is T, then here tension should be 2T. And if tension is 0, then 2T is also equal to 0. So on this 10 kg block also tension is 0. On the 20 kg block also tension will be 0 itself. So if tension is 0 and if these masses are having a mass of 10 kg and 20 kg, then the only force acting them will be acceleration due to gravity. The only force is force due to gravity. That is only weight of these bodies is acting and tension is not pulling these bodies upwards. Then definitely I can say this 10 kg body and 20 kg body, they will be just like freely falling bodies. So therefore I can say acceleration of 10 kg body is equals to acceleration of 20 kg body is equals to minus g. Or I can say both of them are coming down with an acceleration due to gravity. Now let us study, we have to also calculate what is the accelerations of these blocks also here. So first let us take pulley number 1 here, or let us take pulley number 2. So this is pulley number 2 here. So what are the different accelerations which are present? So the block of 20 kg, it is coming down with an acceleration of g. So acceleration of this block is g here. So therefore acceleration of the pulley is also g in this condition. Now we will write these two ropes which are attached to this pulley, and let their accelerations be acceleration of A and acceleration of B. So these two strings are, these are our assumed values. So these two strings are having an acceleration of A and AB. AA and AB accelerations, they are coming down with these accelerations. Then how can I write a relation between them? We have a relation for acceleration of a pulley block system. Acceleration of A plus acceleration of B is equals to 2 times of acceleration of pulley. So therefore I will write, here I will consider downwards direction to be positive and upwards direction to be negative. So I will write acceleration of A plus acceleration of B is equals to 2 times of acceleration of pulley is G here, because pulley is attached to the block itself. So therefore I will write plus G, because downwards direction I am taking to be positive. So this is my equation number 1. Now I will consider this pulley P1 here. So on the pulley P1, these are the different strings which are attached. So here there is a 10 kg block which is coming down with an acceleration of g here. Now if we see here, this rope is attached to both the pulleys, pulley P1 and pulley P2 here. So that is we are discussing about this rope which is attached to this pulley as well as this pulley. So here if acceleration is AA and if it is coming down, then here also acceleration should be AA and it should be coming down. Now if we discuss about this string which is attached to this pulley and which is attached to this pulley P1, then we are saying that this is having an acceleration of AB, our assumed acceleration is AB. So same AB should be acting on this pulley also, but in opposite direction. So therefore I can write this string is connected to this pulley and it is moving upwards with an acceleration of AB. These are the different accelerations which we have assumed in this condition. So here also again I can write the same relation. Acceleration of A plus acceleration of B is equals to 2 times of acceleration of pulley here. So to this system I will consider this is block A, this is block B, and this is the acceleration of the pulley. So therefore I can write this is coming down with an acceleration of G and it is coming downwards, and downwards direction I have taken negative. Sorry, positive. So G plus acceleration of B is upwards in this condition. So therefore I will write G, this is our B, acceleration of, this is block A, this is block B, and this is the acceleration of the pulley. And acceleration of A is downwards, so plus acceleration of A is equals to 2 times of acceleration of pulley. Pulley is moving upwards with an acceleration of AB, so minus AB. So therefore, G plus AA is equals to minus 2 AB. So this is my equation number 2. Now I am supposed to solve these two equations and let us see what is the answer I will get here. So the same equation I can write it as AA plus 2AB is equals to minus G. And this equation, if I take the negative of this equation, then I can write minus AA minus AB is equals to minus 2G. So I will write, I am going to rub this one. So therefore if I add these two, then the result which I am getting are, these two are getting cancelled. So 2AB minus AB is equals to minus 3G. So AB is equals to minus 3G. This is our answer which we got. So what is AB here? AB should become the acceleration of the pulley number, which pulley this we are considering? So this is pulley number 1, P1. So minus indicates that this AB is not directed upwards, it is directed downwards, because we have taken the direction of downwards direction to be positive and upwards direction to be negative. So these are the accelerations of the pulleys also. So therefore this pulley is coming down with an acceleration of plus G, that is coming down with an acceleration of minus G, and this pulley we got answer as minus G, so therefore it is coming down with an acceleration of 3G. So these are our answers. Let us see this problem. So this is a 20 kg block, 12 kg block, which are attached by a uniform rod whose mass is equals to 8 kg. And on this total system, we are applying a force of 480 Newton. Then I want to calculate what is the tension developed at the center of this rod. This we are supposed to find out. So to this force, this total system, I can take it as a single body. So therefore, how can I write the free body diagram of this one? So I can say a force of 480 Newton is acting upwards, and total weight of this body will become 20 plus 8 plus 12 is equals to 40 kg multiplied by the G value is 40 into G, and total system will accelerate in upwards direction with an acceleration of A. So definitely I can say 480 should be greater than 40G. So therefore, according to Newton's second law, how can I write? 480 minus 40 into G is equals to 40 into A. So therefore, 480 minus 400 is equals to 40 into A. So therefore, A is equals to 80 by 40 is equals to 2 meters per second square. So it means the total system will accelerate with an acceleration of 2 meters per second square. Now let us see how we can calculate tension exactly at the center of this rod. So what is the purpose of this tension? What a tension is doing here? This tension is giving acceleration to remaining half part of the rod and 12 kg of rod here, 12 kg mass here. So as this is a uniform rod, if you take the center point of this rod, this part should be 4 kg and the remaining part should be 4 kgs here. So therefore this tension is responsible for producing acceleration in this 12 kg as well as 4 kg block. So therefore, if I draw the free body diagram of that condition, then tension, it is producing acceleration in 4 plus this 12 is 12 into total 16 into G, and acceleration A is equals to 2 meters per second square in upward direction. So therefore definitely I can say this T should be greater than this weight of this 4 plus 12 kg blocks. So therefore T minus 16 into 10 is equals to 16 into A. So T is equals to 160 plus 16 into A value is T 2. Therefore T is equals to 160 plus 32 is equals to 192 Newton. So this is the tension exactly at the center of this rod. So this is the given question here. So there are two inclined surfaces, one at an angle of 30 degrees, another at an angle of 15 degrees. So between these two inclined surfaces, there is a ball of mass of 5 kg, and it is given that this ball is in equilibrium. Then we are supposed to find out the normal reactions of these two inclined surfaces on this 5 kg ball when it is in equilibrium. This we are supposed to find out. So let us see how we can draw the free body diagram of this 5 kg ball here. So on this 5 kg ball, this is one inclined surface and this will be the another inclined surface. So definitely we can say that this inclined surface will give normal reaction perpendicular to the contact surface in this direction, and if this angle is theta, then this normal reaction will make an angle of 30 degrees with the vertical direction. So therefore, how can I draw the normal reaction to this inclined surface? This becomes the normal reaction and let it be N1, and with respect to vertical, it will make an angle of 30 degrees. If this angle is 30, geometrically we can prove this angle is also 30 degrees. Similarly, if you talk about the second inclined surface, it also gives a normal reaction exactly perpendicular to the contact surface. But this inclined surface is totally at an angle of 30 plus 15, totally 45. So therefore it will make this normal reaction N2 will make an angle of again 45 degrees with respect to the vertical. So therefore that normal reaction I can represent like this. So this is N2, the normal reaction given by the second inclined surface on the 5 kg ball. So this again makes an angle of 45 degrees. So these are the two normal reactions which are given by the two inclined surfaces. So in addition to these two forces, this 5 kg ball will have a weight of 5 into G, that is 50 newtons also, which is acting in downwards direction. So if this ball should be in equilibrium, then all the horizontal forces must be balanced and all the vertical forces also must be balanced in this condition. So therefore this N1 I will try to split into two components now. So this is how I can split them. This is 30 degrees. So this becomes N1 cos 30 and this becomes N1 sin 30. Similarly, this N2 vector I will try to split again into two components. So this is N2, this is 45. So N2 cos 45 and this is N2 sin 45. Clear? Now if we discuss about the horizontal forces, so N1 sin 30 and N2 sin 45 are the two horizontal forces and they must be balanced. So therefore N1 sin 30 is equals to N2 sin 45. So N1 into 1 by 2 is equals to N2 into 1 by root 2. So N1 is equals to N2 into root 2. So this is my equation number 1. So up to here I got here. Now I am supposed to balance the vertical forces also. So in this condition, if I see N1 cos 30 is one vertical force, N2 cos 45 is the vertical force acting downwards, and 50 newtons is the weight component. weight of this ball which is also acting downwards. So again these vertical forces must be balanced. So what is the only force which is acting upwards here? N1 cos 30. So N1 cos 30 should be equal to, and the downward forces which are acting in this condition are, one downward force is 50, another downward force is N2 cos 45. So these are the two forces which are acting. So for N1 already we have derived a relation here. N1 is equals to root 2 times of N2, that I will substitute here. So root 2 times of N2 cos 30 is equals to root 3 by 2 is equals to 50 plus N2 cos 45 is 1 by root 2. So if I simplify this relation, then what I will get, N2 into root 3 by root 2 is equals to 50 plus N2 by root 2. So if I multiply every term by root 2, then the equation which I will get is N2 into root 3 is equals to 50 root 2 plus N2. So if I take N2 common, then N2 into root 3 minus 1 is equals to 50 root 2. So therefore N2 is equals to 50 root 2 divided by root 3 minus 1. So this is my answer for N2. So that is the normal reaction given by the second inclined surface on 5 kg block. And therefore I can calculate N1 also, because N1 is equals to root 2 times of N2. So root 2 into N2 value is 50 root 2 divided by root 3 minus 1. Root 2 gets converted into 2. So 100 divided by root 3 minus 1 will be my N1 value. So this is the given question here. So we are supposed to find out what is the maximum height attained by the mass m when this 4m falls down when from a height of h. So that is, by the time this 4m reaches this ground, so what is the maximum height this mass can move upwards? That we are supposed to find out. So first of all, we will try to derive a constraint relation between this m and this m. So definitely this is a single string, tension should be equal. But because there is a movable pulley here, acceleration of this mass and this mass will not be equal. So therefore if I consider here tension is T, then here also tension is T, and here also tension will be T itself. So then here tension will be 2T, and now I will apply the virtual work method. So that is, here 2T is pulling this body upwards, but it will come down. So therefore the angle between 2T and motion of this body is, they are in opposite direction at an angle of 180 degrees. So if I take this acceleration to be A and this body moves upwards, so let that acceleration is A dash, and let us try to derive a constraint relation between these two accelerations. So therefore I can write for 4m minus 2T into, we will write from here, so minus 2T into acceleration is A, and in this condition tension and acceleration both of them are in same direction, so I can take them positive. So T into A dash should be equal to 0. So T gets cancelled. So A dash is equals to 2A. So this is our equation number 1. So therefore if this block is coming down with an acceleration of E, this block will move upwards with the double acceleration to the acceleration of this block. So therefore A dash is equals to 2A. So this is our first equation. Similarly, when this block comes and touches this ground, then I can say this mass will move upwards by height of 2h. So this we can calculate by using the calculus relations xa plus xb is equals to 2 times of xp. Or very simply I can say that if this pulley is coming down by height of h, then it will pull h height from this side and h height from this side also. But this side it is tied here, so it will pull total 2h from the same side. So if this pulley comes down by h, then it will pull a height of 2h from the same side, that is this mass will move upwards by 2h. So definitely I can say this block will move upwards For example, if this is h, and I can say this body may move up to here, and this height I can consider to be 2h. So this is the height traveled by mass m. By this 4m touches this ground, which is at a height of h here. Okay. Now already we have calculated the relation of accelerations, constraint relations. Now we will try to find out what is the actual accelerations of these bodies by applying the Newton's laws. So for 4m mass body, so let us see how many forces are acting here. 2t is acting downwards, 4mg is acting, 2t is acting upwards, 4mg is acting downwards, and acceleration a is downwards. Definitely 4mg is greater than 2t here. So therefore the relation I can write is 4mg minus 2t is equals to 4ma. So this is my equation number 1. Similarly, now I can write the Newton's laws equations for mass m here. So if I draw the free body diagram of this mass m, mg is acting downwards and tension is acting upwards, and body is accelerating upwards with an acceleration of a dash is equals to 2a. So therefore how can I write the relation? T minus mg is equals to ma dash, or m into 2a. So this is my equation number 2 here. So let us write both the equations in this condition. So this is 4mg minus 2t is 4ma. So t minus mg is m into 2a. So this equation number 2 I will try to multiply with 2 here, total equation. Then the equation which I will get is 2t minus 2mg should be equal to 2 into 2ma is 4ma. Now to this equation I will try to add equation number 1 here. So which is 4mg minus 2t is equals to 4ma. So 4mg minus 2t is equals to 4ma. Now if I add these two relations, plus 2t and minus 2t gets cancelled. So 2mg is equals to 8ma. So m gets cancelled. So therefore acceleration is 2g by 8 is equals to g by 4 meters per second square. So this is the acceleration of 4m block, which is equals to g by 4 meters per second square. Now if acceleration of this block is g by 4, then acceleration of this one should be 2 times of this one. So that is the constraint relation we got, a dash is equals to 2a. So therefore acceleration of block m, that is a dash is equals to 2 into a, that is 2 into g by 4 is equals to g by 2 meters per second square is the acceleration. Okay. So therefore this body, it will, by the time it touches h, this will move by height of 2h with an acceleration of g by 2 meters per second square, and I will consider its initial velocity to be 0. Then by the time it reaches to a height of 2h, we will try to find out what velocity it is having. So how can I calculate that one? I can calculate that one by using v square minus u square is equals to 2as. Final velocity square is initial velocity is 0. Acceleration of mass m is g by 2, and by the time it reaches h, this will reach to a height of 2h. So instead of s, I will write 2h. So 2 and 2 gets cancelled. So v is equals to root 2gh. I got answer up to here. So by the time this mass reaches to a height of 2h, it will attain a velocity of v is equals to root 2gh. So if it has attained this velocity, definitely body will move further to another particular height. So that height, now it is moving under the acceleration due to gravity, because this body has already touched this ground now. So after reaching to a height of 2h, now this mass is moving under acceleration due to gravity. So again I will use the same relation. So from 2h, again I can calculate v square minus u square is equals to 2as. So after this m, if it reaches to the maximum height, then final velocity becomes 0, 0 minus, and at a height of 2h, it is having an initial velocity of root 2gh. So root 2gh whole square is equals to 2 into minus g. Instead of a, I can write minus g into, instead of s, I can write yes, that is, or I can write g here, d here, the distance traveled by the mass. So therefore minus minus gets cancelled. So 2gh is equals to 2g into d. So 2g gets cancelled. So d is equals to h. This is the relation I got. That is, from by the time it reaches h, this has reached to a height of 2h. And here it has a velocity of root 2gh. Therefore, it will move again further by how much distance? That distance we have calculated to be d is equals to h. So therefore, total height travelled by this mass is 2h plus h is equals to 3h. Therefore, total height travelled is 2h plus h is equals to 3h. So this should be our answer. Now let us see the concept of weighing machine here. So for example, a person is standing on this weighing machine. Then this weighing machine will show a certain reading in this condition. So let us assume the weighing machine and the man, everything are in rest position, their velocities are 0, accelerations are also 0. Then if I draw the free body diagram, if mass of the man is m, then his weight mg is acting downwards, and this weighing machine will give a normal reaction of n here. So therefore definitely I can say n is equals to mg. The normal reaction given by the weighing machine is nothing but weight of the person in this condition. And weighing machine always shows mass of a person. Therefore, reading can be written as n by g. That is mg divided by g, which is equals to m. This will be the reading of a person. Now let us see one more condition here. For example, this is a weighing machine. A person is standing here. He is not standing just simply, he is holding a string like this. And a string is developing a tension of T in this condition. Now here if I draw the free body diagram of the man here, then this tension T which is developed in the string, he is pulling the person upwards, and a normal reaction is pushing the man upwards. Normal reaction given by the weighing machine on the person will be upwards always, and weight of the person mg is acting downwards. So as he is just holding this string, definitely I can say again the total system is in equilibrium. Acceleration is 0, velocity is also 0. Therefore, upward forces and downward forces must be balanced with each other. So therefore, n plus t is equals to mg. So therefore, n is equals to mg minus t in this condition. So in the previous condition, I got n is equals to mg. Mg, but here n is equals to mg minus t only. And weighing machines always they measure normal reaction given by them on the body which is placed on them. So this is a very important property which we have to understand. Weighing machines always read or always measure the normal reactions given by it on the body. Okay. So weighing machines always measure how much normal reaction they are giving on the bodies. But in every condition, normal reaction may not be equal to weight of the body. That's what we have proved here. Here exactly normal reaction is equals to weight of the person. But here normal reaction is less than weight of the person. And here we will get a lesser reading because here normal reaction is lesser. So these weighing machines always show the normal reactions given by them on the body which is present. So now let us study some more conditions about this weighing machine. So let us consider this weighing machine is on a person is standing on a weighing machine, and this total system is moving upwards with a velocity of v here. So if velocity is v, definitely I can say acceleration is 0. So if acceleration is 0, I can say net force acting is 0. If net force is acting is 0, then definitely I can say upward forces and downward forces are equal. So therefore, if I draw the free body diagram, so this is the normal reaction given by the weighing machine on the person, and mg is the weight of the person, then I can say n is equals to mg. So therefore, reading of the weighing machine is equals to n by g. So mg by g is equals to m. So that is, weighing machine will read the total mass of the person. In this condition, it is not a problem. Similarly, if this total system is coming down with a velocity of v, then what will be the reading shown by the weighing machine? That we can also calculate. So again, as this total system is moving down with a velocity of v, again I can say acceleration is 0, so net force is 0. Again I can say upward forces and downward forces are equal. So again this becomes the same free body diagram here. So again n should be equal to mg, again reading will be same. So whether total system is moving upwards or downwards with uniform velocity, the reading will be exactly equal to mass of the person itself. Now let us see some more conditions here. For example, this is the weighing machine. Person is standing and total system is accelerating upwards with an acceleration of a here. So if total system is accelerating with an acceleration of a, definitely I can say that upward forces are greater than downward forces. So if I draw the free body diagram, so this is the normal reaction given by the weighing machine on the person, and this is the weight of the person, and they are accelerating upwards with an acceleration of a. So n minus mg is equals to ma. Ma is the net force which is acting on the person who is accelerating with an acceleration of a. So therefore n is equals to m into g plus a in this condition. So therefore reading of the weighing machine will become n by g. So that is m into g plus a divided by g. So this will be the reading of the weighing machine. So in this condition, g effective acceleration has become g plus a. G plus a. So definitely the weighing machine will show a greater reading. Clear? Similarly, if I study one more condition, this is the weighing machine, person standing on the weighing machine, and total system is accelerating down with an acceleration of a here. So if acceleration direction is downwards, definitely I can say downward forces are greater than upward forces. So definitely I can say this is mg, and this is the normal reaction given by the weighing machine, and acceleration is downwards. So mg minus n is equals to ma. So therefore mg minus ma is equals to n. So n is equals to m into g minus a. So here g effective value is equals to g minus a in this condition. So definitely I can say the weighing machine will show a lesser leading when compared to the actual mass of the person, because effective g value has reduced here, and weight of a body is only because of net acceleration due to gravity. Clear? So now my question is, so if this weighing machine should show 0 reading, then what is the condition? So reading should be completely 0, that it should show that this person is not having any mass at all. Then let us see how we can understand that situation. So this is the weighing machine, and on this one a person is standing. Let us assume that this total system is freely falling with an acceleration of g. So therefore, if I draw the free body diagrams, mg is acting downwards, normal reaction is acting upwards, and A is equals to G is acting downwards. So therefore, I can write mg minus n is equals to m into G. So mg gets cancelled, so n is equals to 0. So therefore, the weighing machine will show 0 reading when the body is freely falling. So these are the different conditions we have in the case of weighing machine concept.